Now we'll study metrics that we can use to evaluate regression models. The first one is called mean absolute error. In this example, we have some points and we have drawn a line that fits these points. Now we would like to check how bad is this line. A good way to do this is to just add the absolute values of the distances from the points to the line. Mean absolute error is very easy to calculate in sklearn. What we do in this example is to create a linear regression classifier object called classifier. Then we use the function to fit the line. Now we can refer to the points as y and to the predictions made by the model as classifier.predictx. We will call this guesses. And finally, the mean absolute error is just calculated with the mean absolute error function. The mean absolute error has a problem, which is that the absolute value function is not differentiable, and this may not be good if we want to use methods such as gradient descent. To solve this problem, we use the more common mean squared error. For this metric, we add the squares of the distances between the points and the line. Mean square error is also very easy to calculate in sklearn, except now we will use the mean square error function. Now we'll learn a very common regression metric called R2 score. R2 score is based on comparing our model to the simplest possible model. So let's think, what is the simplest possible model that fits a bunch of points? Well, a pretty simple one is just to take the average of all the values and draw a horizontal line through them. And we can calculate the mean squared error for this model. We would hope that the mean squared error for the simple model is larger than the error for a linear regression model. The question is, how much larger? Well, we can divide the error for the linear regression model by the error for the simple model, and then subtract the result from 1, and we will call this the R2 score. If the model is not very good, then the two errors should be similar, and this quantity here should be close to 1, so the whole R2 score should be close to 0. If the model is good, then the mean squared error for the linear regression model should be a lot smaller than the mean square error for the simple model. Therefore, this ratio should be small, and then the R2 squared should be very close to 1. In conclusion, if the R2 score is close to 1, then the model is good. And if it's close to 0, then the model is not much better than just guessing the average of the values of the points. R2 score is very simple to calculate in sklearn with the R2 score function. Here's a small example where we calculate the R2 score between the true values in blue and the predicted values in green.